Try IETF. Which one are you connected to? Yeah. IETF. No. IETF should be the other one. Yeah. Okay. I think we're ready to go. It's 7:30. Good morning, everyone. Welcome to the first session of OAUTH. Great to see you again here. And let's get going. There you go. The note well. If you're not familiar with this, please take a minute to review this. This governs everything that we do at IETF. So it is important that you understand what's going on there with this one. These are tips to make sure you're able to join and contribute here if you need to. So please, if you are in the meeting, use that Meetaco Lite client. That will allow you also to kind of join the queue if you want, and we would know that you've been in the room. So it's important that you kind of use that while you're here, and please wear a mask during this time, unless you want to speak up. For remote participant, please use the full remote client. Make sure that audio and video are off unless you want to say something, and we highly encourage that you use a headset if you're remote. Okay, so we have 4 sessions, 2 official sessions. The first one is obviously today, this one. The second one is on Wednesday at 1 o'clock. And we have 2 side sessions. The first one is Tuesday at 2, and the next one is Thursday at 2 at the same time in the same room. The one on Tuesday, we have allocated an hour and a half. Probably we're going to use only the first hour because we probably have a conflict with another working group, but that's for the side meeting. Okay, so work group updates. Since last time, we published JWK thumbprint URI. So this is Mike's and Christina's document. So congratulations to Mike and Christina. I think special congratulations for Christina. I think this is your first RFC at IETF. So thank you for that. Thank you for contribution. IETF last call, we have a RAR document at this stage. In the RFC editor queue, we have JOT response for OAuth token introspection. So, Roman, what is the status of this? This has been there for some time. Any thoughts on this?
Good morning, Roman Dunity, Responsible AD, and I guess it says something as I got up. I didn't feel like I could leave without grabbing my cup of coffee, and I'm like, wait, no, that's not a good idea. So in the RFC Ed queue, it's in misref, so it's waiting for the security best practices. So there are 2 things to do. We could accelerate the best practices document, or we could look really hard at that document to say, do we need it as a normative reference? Okay, good to know. So I think we're trying to get the best practices out soon. So yeah, maybe let's wait for that, right? Yeah. That's a little bit of a nudge. And then just since I'm up here, just to kind of comment, the Depop document is now in kind of revised ID. So we're moving a little bit.
Yeah, awesome. Thank you. Yeah, we got the feedback from you, Roman, and appreciate that. So we're gonna sorry, the Depop. Yes, exactly. We're chatting about this in the side meeting. I think tomorrow, right? Yeah. Yes.
Working schedules, I think I'll be able to sneak in. I told you.
Yeah. 2:30. 2:30 we'll be there. Yeah. Awesome. And waiting for security shepherd. Actually, for the security BCP, I think like you had some comments, Daniel, that you want to incorporate. I think Mike, you have some other comments that you want to contribute to. So let's Yeah, so let's, if you can get that as soon as possible, let's get this going, okay? And hopefully after that, we'll give Hannes a chance kind of to review it and push it forward as a shepherd for this document.
Can we review the comments in one of the side meetings?
We could, absolutely, yes. Yes. Yeah, that works. Okay. So our agenda for today, besides a chair's update, we will start with Aaron talking about giving us an update on browser-based apps and OAuth 2.1. Daniel and Christina will talk about SDJOT. Brian will give us an update on the step-up authentication. And Ben Schwartz, he's remote. Hopefully he's on the list. Yeah, I see him there. So he will talk about interactive authentication document that he submitted just recently at the end. So that's for Monday. For Wednesday, I'll be talking about JOT embedded tokens. Atul will be talking about fine-grained transactional authorization. Peter will be talking about his new draft that just submitted recently, cross-device flows. And Christina will talk about the client ID for anonymous clients. So that's for Wednesday. Side meetings, Depop AD review. There are a few comments, and we're gonna discuss this directly with Roman tomorrow. There's also some questions, comments from the FAPI working group at the OpenID. We want to talk about that. Go ahead, Roman.
Yeah, in the spirit of keeping things moving, I think we only need to talk about algorithm agility. I'm fine with the number of others. It's not my equity. You just got to document it. I do remember some of the reasons why we got there. We just got to write it down. So algorithm agility is the only thing on my list.
So when you say write it down, just update the Shepherd write-up, or is that good enough?
Yeah, precisely. Because in ISG review, that's like the first question folks see when they open up the document. Like, what you did? I mean, we say less than 5. Why do you got more than 5? And I'll defend why we got there. We just need to write it down.
Awesome. Thank you. We also want to talk about OAuth Workgroup GitHub. I think Aaron helped us kind of get this going, so Aaron will talk about that. Atul will kind of dig deeper into the fine-grained transactional authorization, and then Aaron will have more chance to talk about a browser-based app and OAuth 2.1. I will add the security BCP for Daniel also to talk about that too. And I think that's all we have. Any questions, comments? Okay, if none, let's, Aaron, let's get going. Do you want me to hand you the control?
That'll work.
There you go.
Good morning. I'm Aaron Pracky from Okta. 2 drafts to talk about today, OAuth 2.1 and browser-based apps. We'll start here. Decided to follow Brian's tradition of including photos from the location in slide decks, and I think we should all do that. So that is my personal challenge to everybody else. That was from yesterday, went on a little adventure. So OAuth 2.1, if you're not familiar with this, it's essentially an effort to consolidate the existing OAuth 2.0 drafts and best practices into a document that is easier to read and more up to date on a number of fronts. There's quite a lot of language and references that are now quite outdated in OAuth 2.0, which has just celebrated its 10-year anniversary last month. So been a while. So since the last time we chatted, there's been a little bit of updates to the draft. The abstract has now been updated to remove the term third party, since I think a lot of the use of OAuth today is actually in first party as well as third party. So now it just applies to everything. Also, part of the motivations of using OAuth is to enable things like multi-factor auth and passwordless auth. So that's now added to the introduction as well. As we talked about last time, push authorization requests is an interesting kind of exception to the requirement that is described elsewhere as needing to register redirect URLs everywhere. That is now mentioned as a way that registration can happen, because it's effectively on-the-fly registration of the redirect URL. There's a mention of if your token endpoint is going to be used by browser-based apps, you'll need to support the CORS headers, although that's something else we're going to have to talk about in a little bit. And some updates to references and little fixes here and there. So overall, not a ton of changes there. Since the spring meeting, these are some of the changes as well. I think we talked about all of these last time in Philadelphia, if you were there, so I'm not going to go over them one by one. I do have links on the slides to the GitHub repo that talks about all of the issues that were closed or discussed during this round of changes. And there's also the link to the diff of draft 5 to 7, which was from July to now. And you may notice that it's at a new GitHub org, which we will also talk about in the side meeting. Couple of things that are still just sort of on the path to do, which have some of these have now been on the to-do list for a long time because they're just big tasks. Any help is appreciated on any of these. But Justin and Vittorio's write-ups, still working through their write-ups from the original draft of this. A lot of that is now dealt with and closed and revised by various things, but there's still just a little bit more left in those write-ups to get to. There's still the rather large task of identifying any normative language that may be in various sections like security considerations and moving, where appropriate, back up to the actual core document main part of the draft. And then one thing that we had identified at one point, I don't remember which meeting it was at, adding an explicit section talking about the core differences from OAuth 2 and which changes are breaking changes to who. Because essentially, if you are following the best practices today, that it already is 2.1, but that is quite different from original OAuth 2 as described in 6749. So we will make sure to document everything so people can know what to look for when they want to go and double check that their current OAuth 2 systems are actually following the best practices. There are a few more issues that I didn't pull out specifically here. Feel free to take a look on the GitHub repo if you are interested, and we'll be just working through those on GitHub. A couple things I did want to talk about here in particular are some things that either I felt were particularly relevant to a synchronous group discussion, or things that, well, one of them was something that needed to get pulled from the side meeting to the real meeting. So cross-origin resource sharing. There's in one of the meetings, we identified that the token endpoint needs a mention of supporting cross-origin resource sharing. So that was then added. And then that's really the only endpoint in the core draft, but there's a whole bunch of other endpoints that are defined in extensions to OAuth 2.0 that are pretty commonly used and widely deployed that will also need cross-origin resource sharing support. And I think it's worth mentioning in particular in the core draft, there may be extensions that require this as well. And that would be things like the metadata endpoint or the PAR endpoint or what those kinds of things. And in addition, the authorization endpoint itself, which will be visited by the browser, not used by JavaScript, actually should explicitly not allow cross-origin requests because bad things can happen if so, which means essentially there should probably be a CORS section in OAuth 2.1 that talks about this as a whole instead of just one mention of it somewhere. And in OpenID Connect, this discussion's also been happening. And I think we need to sort of have a general agreement on the language that goes into both of these, which also applies to security BCP. So essentially, my thought is to add a section about CORS, mentioning explicitly not allowing CORS at the authorization endpoint. To support JavaScript apps, then you'll need to support CORS at the following endpoints that are either defined in OAuth 2.1 or in extensions that are already being referenced in the draft. These are the four that I found quickly. If anybody knows of any others that are worth pointing out specifically, suggestions are welcome. That links to the issue 133, where I'm collecting this stuff right now, so feel free to go in there and add suggestions if you have any other ideas for things that would be useful to mention around general CORS recommendations for OAuth.
So
I think,
do you want to take comments here
Sure,
on
yeah.
this topic? So anybody has any comments? I noticed some nods there, but beyond nods, go ahead.
I just want to ask you, bring up.
Sorry, can you state your
Sorry,
name? first?
Daryl Miller from Microsoft. You mentioned JavaScript apps, but I'm just wondering in this world of WASM now, how CORS interacts with WASM and whether we should say that more broadly.
that is a great point. Probably worth not using the term JavaScript in reference to CORS anymore. So yeah, we'll figure the right language for that, probably just browser-based apps. Oh, I see Brian. Sorry? Oh,
Brian, go ahead.
Brian Campbell, Ping Identity. I'm totally on board with all this. I think it's a great way to go. Along the same lines of trying to explain the difference between used by browser-based apps and used directly by browser-based apps, because like the authorization endpoint is going to be used by these apps, and it's the nature of the use that I think is both the reason for not exposing it to CORS and Coors. That's the beer from where I'm from. That's not really beer, Coors, and how it's used. That's sort of the heart of the issue, and I think everything you're saying is right on, but actually really explaining how that works in good language that I don't have, but am suggesting you write is good. So
thanks.
thanks,
Yeah.
Aaron.
No, I totally agree. And I think that actually is a great example of why this requires like a dedicated section to talk about it, so we can actually explain exactly those points.
So Mike Jones, Microsoft, as I was doing the errata edit for Connect about this, I was the one who came up with the used directly by versus used via redirect, but I would love somebody to give me a short phrase which connotes using HTTP verbs such as get, post, whatnot. What is that action without being verb specific? Navigate is a redirect.
To the mic, Danielle, if you want to speak up, please go to the mic.
I'll sit down, but that amplifies what Brian just said. We need that language.
Yeah. I agree. I think we'll have to do a little bit of work to figure out the specific language for it, but I agree that like, yeah, we need to be very clear about whether the browser is the one making the request or whether your JavaScript or other languages that run in a browser making a request itself directly. I don't know the right term for that. So, but it sounds like we're at least all in agreement on the concept. So, cool. Yeah, feel free to add suggestions into that GitHub link if you have any thoughts about the language that would be useful to use in the section. Cool. Okay. Moving on to new issue 54. This was an older discussion that we brought up during the side meeting last time we met. Had a brief discussion about it, and then it continued to get a comment or two on GitHub. At the token endpoint, there's a list of parameters required to exchange an authorization code when exchanging an authorization code. One of them is the redirect URI. There's language in the original spec that says send the redirect URI to avoid certain types of mix-up attacks. And it's arguably not a bulletproof solution by any means in the original spec, but it actually has zero technical purpose once you are using Pixie. It doesn't actually do anything else. Pixie solves the mix-up attack that redirect URI barely solved to begin with. So my question was, since we're cleaning this up, can we just leave it off because it doesn't do anything? And there was a discussion. We do want backwards compatibility, of course. We shouldn't make it so that OAuth clients are going to suddenly stop working if they're sending the parameter, for example. So the question is, how do we support that while also not just having it required for the sake of it because it's always been there? The options are anything from just not documenting it and letting people just do it or not. There's also making it required that the AS would accept and also verify it if sent, but not require it to be sent, which feels like the right way to do backwards compatibility, I think. Other options, or just leave it alone and just keep it as a required parameter because maybe that's just the simplest and anything else is adding new problems. I'm on the fence about it, but it feels like an opportunity to like clean things up because every time I'm explaining this to a developer and I'm like, send the redirect URI parameter because I don't know, we've just always done it this way. It's like not terribly compelling. So that's, I would like to actually have a quick discussion here about this.
Go ahead, Mike.
Mike Jones, Microsoft. I suspect that some code is going to break because when it's not sent, because it's expecting it to be there. And I think that by itself
On the AS.
Yeah, is probably enough reason to keep it either as recommended or required. I would be fine with a note being put in saying this is effectively redundant when you're using Pixie, but
I think for the backwards compatibility discussion, it's like you have to consider which end it's breaking on. And I think for the AS, like obviously if the client's not doing Pixie, this is marginally useful. So if the client's not doing Pixie, then you're not doing the OAuth 2.1 flow to begin with. So if the AS supports OAuth 2.1 or requires it for a client, it feels like it's okay for it to just ignore the parameter and not require it. Because if you're already opting into the new behavior in the spec, then there is nothing to break there. But yes, for an OAuth 2.0 authorization server, obviously we're not saying OAuth 2.1 clients are expected to work with 2.0 servers because that's not the backwards compatibility. That's not backwards, that's just forwards compatibility, right?
And you have +1 from George.
Okay.
Go ahead.
Aaron, what type of compatibility do you want? Would you want a 2.1 client talking to an old 2.0 authorization server? Would that be something that is actually okay? Or because that's where the problem shows up.
Again, because 2.1 is not supposed to be an entirely new thing, it's supposed to be the collection of best practices. If an AS is already supporting best practices, then
it's not a 2.0 in that definition.
Then it should be considered a 2.1 AS already, right?
Okay. So naturally, that the issue shouldn't pop up. Is strictly speaking, like if you follow best practices.
I believe so. So if a OAuth client is, if an OAuth 2.0 client was talking to a 2.1 server and it does send the redirect URL, we don't want the AS to reject it. So it should ignore it because it doesn't serve any purpose, which is already what it's supposed to do with unknown parameters, basically turning it into an unrecognized parameter. And then if a OAuth client opts into the 2.1 behavior, it should work with OAuth servers that are following the best practices. So if it's not sending it, then we only want to let that break if everybody's agreed on the new rules, right? I believe that's the logic we're trying to follow here. If everybody agrees on the new rules, then everybody plays by the same rules. But if one person doesn't, then it's okay if it breaks, as long as it's not rejecting it if it's sending the parameter from. Does that make sense? I'm seeing some nods. It's definitely confusing. It sounds like, and then the option 2 here that I have on the list of making a note of if the client does send it, then the AS should also check it because that's how it can support older clients. So that's the sort of backwards compatibility note.
Go ahead, Daniel.
Daniel Fett, yes.com. Just saying, so this is obviously not something we will do in the security BCP because it's not security related. So we cannot really say there, you may omit that parameter and everything will be fine. So we have to be careful not to introduce like another level of compatibility. So you have security BCP compatible, and then 2.1 compatible diverging when you introduce this change, potentially diverging. So maybe it's better to leave it as is. So if we say that if you follow security BCP, so like 2.0 and security BCP, you're essentially at the same like level as 2.1. And now we're introducing something else in 2.1, which may break the security BCP compatible stuff. That might complicate things further. So as much as I want to get rid of this thing as well, but yeah.
Okay. Thank you. Philip.
Thank you. This is Philip Skokam from Okta. I would just like to echo what Daniel said. If the point of 2.1 is to take 2.0 and apply all the best practices, it doesn't feel like removing, it would create a new world, despite me wanting to get rid of this because it makes the APIs for consuming callbacks also ugly because you always have to redirect URI and you're trying to do magic in browser-based applications by putting your current URL in there. I feel like the ship has sailed on this, and rather than create a whole new world, I would just keep this as is.
Thanks,
because
Philip.
also, if like you said, if I have an existing OAuth2 server and it applies all the security best practices, and then a 2.0 client talks to it, it should just work. Even 2.1, it should just work because it has all the BCPs applied. But if it doesn't send the redirect URI, it wouldn't.
Yeah, it is. Yeah, the question is whether a 2.1 client would work with a 2.0 server that has done all the best practices stuff.
Right.
Which, yeah, it does sound like it is creating a new class.
In that case, if there was a discovery mechanism, we can do this. Like if the client can figure out this is actually a 2.1 compatible server, yeah, why not?
So that actually brings up an interesting point, which I'm pretty sure is, I'm pretty sure that there's nothing else like this yet in terms of things that 2.1 defines that are not described by the security BCP or other drafts. If there are, though, then it seems like we would need to go down that road of discovery flag, and then it would be okay to include this. But I don't think there are any other things like that yet, but it seems like it's worth double checking.
Justin Richer. So if we do option 2, like Aaron's suggesting, we don't actually have to do discovery because no matter what the client does, the AS is going to do the right thing if it's a 2.1 compliant AS. If the client doesn't send the URL, AS is going to be fine with it. If the client does send the URL, the AS is going to check it and enforce that it's the right thing. So if you get a client with old behavior or a client with new behavior, it's fine. You don't have to discover anything, and it all just works. Option 2 is the only one up there that actually makes sense. Everything else is a bad idea.
The only that works great for the 2.0 and 2.1 client talking to either 2.0 or 2.1 AS. However, that doesn't work with the 2.1 client talking to the 2.0 plus BCP AS. That's the one that it breaks. And if we're okay with that breaking in that direction, then that's fine. That's the only one of the 4 combinations that breaks.
And I see nods, so are people comfortable with that? And if that is the case, let's just make sure it's documented and clear, right?
Okay.
Okay.
Seems
like everyone
seeing
is,
general nods and
looks like it.
okay. Was there somebody who popped up on the queue or did that?
No, I don't see anybody
Okay.
in the queue. Yeah.
What's the way forward?
The way forward is basically number 2 on the slides. So AS for backwards compatibility should accept and verify the redirect URL if present, but not require it.
And make sure that the combination that you've talked about at the end is documented and clear that it's a breaking.
So that goes into the section I mentioned earlier of the
Right.
OAuth 2.0 compatibility section. That will have to get called out explicitly.
Right. Philip, did you have a comment there? I noticed you joined and dropped.
I wasn't sure if we're okay with that breaking. Personally, I'm not, but if the consensus is, let's just document that breaking behavior, sure. But I'm not 100% sure that should be the outcome, unless there's discovery.
My gut feeling is that it's okay because the clients they're frankly less likely to update in general unless they need to for some reason, just because if things work, then they're just going to let it work. So if they want to update, then if they go update to what's labeled 2.1 compatible or a 2.1 client, then they won't be expecting it to necessarily work with the 2.0 server anyway, just because there probably are going to be other things that break just because 2.0 is such a broad term to begin with. So it feels like it's the okay direction. And I agree that I would be less willing to have the AS be the one that it breaks for.
All right.
Maybe the other thing to note here for the action items, once I do add the section that talks about all the changes from OAuth 2 and who they break for, let's just revisit this because it may make sense. It may show up as, oh, it's not a big deal. There's other things that break in that direction. Or if it's maybe the only one that breaks in that direction, we can change our mind about it. I feel like once we get that full picture, we'll have more context for it.
Yeah, good idea. Okay.
Okay, cool. Okay, yeah, that was it for the 2.1 issues. There are a couple other things on GitHub that are open, so feel free to jump in there with any thoughts. But with any luck, we're coming down to the end of it here. Okay, moving on to the browser-based apps best current practice. This is now draft 11 after picking it up in July, again, after some time away from it. So we had a little discussion in July and quick recap of what this draft is supposed to do. It's supposed to be recommendations for people who are building browser-based apps using OAuth, which are defined as applications executing in a browser, aka single-page apps. The language is not actually mentioned in the draft because it applies to any browser-based execution environment. And it may include a backend component that is part of the interaction of the application having its own sort of backend. Since July, there's been some more reworking of the document. There are these 4 architectural patterns that are called out in the draft in terms of they're like different ways that you might organize your app or architect your app. The single domain architecture is just when your client runs at a URL that's the same domain as the AS. There's the these names are names that have changed, but the patterns have been there for a while now. Backend for front end proxy, that's the one where the backend basically has its own session to the front end, and the backend does everything. It acquires the tokens, it makes API calls, everything about the JavaScript app runs through that backend, where that backend is the OAuth client, is the thing that talks to the resource servers. Then there's the token mediating backend, which I stole from Brian and Vittorio's draft, where the backend is only responsible for acquiring the tokens, and the tokens are then passed to the front end, where the front end makes API calls directly. And then there's the last option, which is token acquisition in the browser, which is essentially the only front end option, where there is no backend at all, and everything happens in the browser. So those are the four patterns, and the token mediating backend is the new one that was added to this based on our discussion last time. There's also now a subsection of the pure JavaScript or pure browser-based app, which talks about using a service worker to manage it, because there are different considerations and different threat models when all of the token management and acquisition happens from within a service worker versus in the DOM directly. So that's sort of like a subsection of the pure browser-based app. And there's also now more notes about things to worry about if you are actually storing tokens in local storage. If you are that applies to both the pure browser-based app as well as the one where the backend acquires the tokens but passes it to the front end, where it deals with the tokens somehow. So if you have feelings about local storage and tokens, which I know a lot of people do, please make sure your feelings are represented in the document. There are no right or wrong answers for this. It is meant to capture the information that is known. And this has been probably one of the reasons why this discussion kind of stalled out last year. There's a lot of differing opinions about handling tokens in browsers. And again, the goal is not to say that one is right or wrong. The goal is to say what is wrong with all of them, because they're all bad in different ways. Okay, so
So before we go into changes, I think you and I talked about the issue of some people storing tokens in cookies. Is that, I think, and this is something that we, as a work group, we don't recommend, but I don't think I've seen it documented anywhere. So would that be covered in this document?
There is I'm trying to think of where cookies are mentioned in here. Cookies are mentioned a couple of times. I don't know if there's any actual mention of using cookies as token storage, though.
Should we talk about this in this document, right?
Probably.
Okay.
Are there strong feelings, hopefully the same feelings about this, about browser-based code using cookies as a storage mechanism? Not talking about the concept of the token mediating backend may set the pure browser, the proxy version where everything gets routed through the proxy. In that model, you need some sort of cookie between the proxy and the client, which may be the token itself. I believe that case is already called out with some notes in the document, but what Rafat is mentioning is the idea of JavaScript code using the cookie API in the browser to actually store things, which it can do. That's not really what cookies are for, but you can use it that way. Local storage is obviously the better solution for storing things in JavaScript. Is that generally a general agreement on that? Because I can make a note about in the local storage section of or around there somewhere of don't treat your cookie API as a storage mechanism. A lot of nods. Okay. Cool. Can you make sure that's in the minutes so I don't forget?
What do you want me to put in the minutes?
Document not using the cookie API as a storage API. Oh, actually, that is relevant to number 2, issue number 2, which it does need an actual section calling out token storage techniques.
Okay.
So there are a few different ways JavaScript apps can handle storing tokens. And again, it's regardless of how the token was acquired, whether it's from the backend or from the browser app doing OAuth itself. But there are you could keep it just in memory where it isn't actually persisted anywhere. You can use local storage, session storage, or cookies, and we'll recommend not using cookies. And then there are reasons to put it in local storage and reasons to not and just use memory instead. And both of those are fine in different scenarios. So we're not going to say don't do one or the other, but we'll have to mention the considerations about both situations. So that's probably the last big section that's going to go in. And then one of the last to-do items, number 6, just go back through the security BCP to make sure that this draft is consistent with it. Hopefully not too much of it is duplicated to begin with, but I know there were some things that were at least like said as described by the security BCP, blah, 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 just to make sure people are finding it. So that'll be one pass to go through that. And I think that's like mostly it, except the new thing that just came up, which is a whole section about CORE's recommendations, which is, I feel like it touches every draft that we're working on right now. So the security BCP, it either does or soon will recommend that the AS on the authorization endpoint not having the CORE's headers. That feels like the right spot for that one to go. That doesn't really apply to the browser-based app spec. It does apply to the security BCP in 2.1 and OpenID Connect. The browser-based apps spec probably should make another mention of all the endpoints that do need CORE's headers to support browser-based apps properly. That feels like an appropriate place to put that. And then OAuth 2.1, of course, like I mentioned, you can basically grab these from both of those drafts to make sure that it's mentioned in 2.1. So nothing really new to talk about CORE's here because we already talked about it in the context of 2.1, but it feels like it is worth putting it into here for people who are reading this draft. And then that would be so yeah, basically 2 sections to add, the token storage section and then the CORE's section. And that hopefully is the end of this draft. And I think that's the end of my slides. Yeah. So yeah, with that, hopefully with those 2 things out of the way, we are coming up on being able to push this one through, push this across the finish line.
Awesome. Great. Any last minute comments, questions to Aaron? Okay. Awesome. So I guess we're not ready to kind of push these forward. We still have lots of work.
Yet. A couple more sections to add. Hopefully, I would very much like to have these sections added and any discussion about the specific text happen over the next couple of months on the mailing list so that by the time we meet next time, there aren't any more planned changes.
Awesome. Perfect. Thank you, Aaron.
All right.
Appreciate that.
Thank you.
Okay. Daniel, I think the slides might not be the last one because I've just approved it. I just noticed that you sent it, but do you want me to, I don't know how to share it otherwise, maybe. Can you send me the slides directly? I'll maybe just display it here. Is there a way to pull it actually? You know, let me see. Oh, shit. Yeah, okay. Let me try to. Where is it? Like is this? Okay. Let me share it and tell me if this is the latest. Do you know which slide that? Okay. Okay, send me. Yeah, that works. Okay. Did you send it to my email? Oh, got it. Got it. Got it. Thanks. Let's see if I can download it here. And maybe share my screen, I guess. Let me see. No, not this one here. Oh, hold on. Join this one probably. Yes. Okay. I guess. Share this one. Yeah, just let me do the full screen. Oh, shoot. It's too much. Okay. I'll have to drive it from here, okay? Unfortunately.
Okay.
Okay, let's go.
No full screen available?
I've tried. This is supposedly, you know what? Let me do this. Hold on.
What's that?
Cancel. Just one. This one?
No.
No. So let's do this. I'm going to do this. Hold on 1 second. Come on. Sorry, guys. Maybe, yeah, from PDF. Yeah, maybe that would be better. View, full screen. Okay. I think this is better.
Okay.
Let me know when to go.
Yeah, no, that's good. I'll just try to adjust this a bit. Okay, hello everybody. We're going to speak about the SD draft selective disclosure for JWTs. This is mostly an update to our last presentation in Philadelphia. So if you're not familiar with selective disclosure drafts, it might be worthwhile to read the draft. Next slide, please. Keep in mind that one of the main design features of SD-Draft is to be simple, so simple to implement, simple to use. So that's what we consider the main feature here. Next slide, please. We did a lot of updates since last time, especially last time. This was still an individual draft, and now this is a working group draft. So thank you everybody for your support. We updated the terminology that is used in the document to be hopefully more clear than it used to be. We introduced what we called a combined format. Actually, we didn't introduce it, but we now properly name it and explain it, the combined format for transporting SD drafts and other data. We moved away from just one hash algorithm to allow in general digest derivation algorithms to be used with the standard, although SHA-256 is still the default. We clarified what you need to do to verify the signature on an SD draft and the data that is disclosed as a verifier. We also hopefully improved our explanation on why we chose this specific encoding that we choose in this draft. We get to that later. We introduced a feature that was often asked for, namely blinding claim names. And we now describe a processing model that we think will be useful to most verifiers in processing SD drafts. Thanks to Aaron, we also now have a repository in the OAuth working group GitHub project or organization or whatever it's called. So this is the place where you need to go if you want to see the latest, like the latest editor's draft, and so on. And with that, I think Christina will speak about updated terminology.
Thanks, Daniel. Daniel gave a great summary, but just to dive into a couple of details. Next slide, please. So we received feedbacks that how each object / JOTs being sent could be better explained, better named, to be more intuitive. So the actual SD JOT signed by the issuer, that part has no changes in terminology. One new part is an object that issuer sends alongside the signed JOT. This object that includes a mapping between plain text claim values, salts, and now optionally claim names that was used to be called SVC, salt value container. Now it's called issuer issued disclosures object. So we're introducing this new concept of disclosures, which is essentially this mapping between for all this plain text values. So this one is issued by the issuer, the original disclosures, and it is not signed, so it's an object. And it's never signed, so it's an object, not a JOT. If you go to the next slide. And also, when the end user chooses out of those issuer disclosures, which of those disclosures, which of those mapping the user actually wants to disclose, that object is now called holder selected disclosures JOT. I think it used to be called releases, and now it's, again, holder selected disclosures JOT, and it's a JOT because when holder binding is required, it could be signed or it could be unsigned. So those are two big concepts. So abbreviations are II disclosures, HS disclosures. So just so people are not confused, it's same concept cryptographically, but different terminology. If you go to the next slide. So yeah, just a summary. And in addition to what I have already covered in terms of actual claim, the property names, SD underscore release in II disclosures is now SD underscore II disclosures, and in the holder selected disclosures, now it's called SD underscore HS underscore disclosures. So you see this throughout the examples in the presentation. And the last bottom bullet point is related to the topic I think I'll cover soon. If you go to the next slides. Oh wow, it's old slides, I guess. Can we skip it? Yeah, skip it. So yeah, from the implementers, we also received the feedback that, if you go to the next slide, people wanted clarification of how these objects are actually being sent, transported between issuer and end user, and then end user and the verifier. So we introduced the concept of combined formats. So combined format of issuance consists of 4 dot separated parts, where the first 3 is a JOT, which is assigned SD JOT, and the last part is base64 euro encoded JSON, which is this issuer disclosures object. And from the end user to the verifier, that's where we introduced the concept of combined format for presentation, which consists of 6 dot separated parts when the holder binding is required, meaning the first 3 are always a JOT, issuer signed SD JOT, but the last 3 are holder selected disclosures JOTs, and the last signature could be optional if there's no holder binding required. So these are the 2 basic units that are going to be transported between these entities. And how they're actually being transported is out of scope, so that's up to transport protocol. But just to clarify that this is a basic unit. And what I'm implicitly saying is if you're sending one SD JOT, you have to send one holder selected disclosures per SD job. So that's an implicit clarification of some of the comments we've received. Next slide, please. So we also received feedback that in the original individual draft, yeah, if you can go to the next slide, we only supported basic hashing algorithm, but we also received feedback that some people wanted to use HMAC or do something a bit more fancier. For example, using really advanced cryptography to make, but with really, really small SOT values, but achieve the same level of security as, really complex hashing algorithm, for example. So that's expanded. So throughout the text, you would see changes in terminology from hash algorithm to a more general digest derivation algorithm, but still SHA-256 is mandatory to implement hash algorithm, and all the security related guidance related to minimum bytes that has to be used, that part has not changed.
I have a short question.
Yeah.
When like the term digest derivation algorithm is a little bit unusual, and then I see two types of algorithms. One is an HMAC, which is a keyed hash function. The other one is like an unkeyed hash function, like SHA-256. So what, in which direction is this going?
So the intention was to accommodate both by using a terminology digest derivation algorithm, which was originally, I think, suggested by Christian Paquin, a cryptographic researcher. But if this is not intuitive enough, the purpose does not change. I think it would be the terminology change, to be honest. And the way we clarified in the spec is, so the SOT value obviously changes. We're using the term SOT throughout the spec for consistency, but obviously if it's HMAC, it's the key. It's not the random SOT value. So yeah, maybe that could be clarified a bit better, but just the main point here is that intention is to allow the usage of HMAC too. Okay.
I think the intention is.
Your name.
My name is Brian.
This is just for the remote people.
Apologies, I forget. The intention, I think, sort of does shine through, but the realization of this is really problematic from an implementation standpoint. Like, you talk about interchangeability of salt and key between hash and HMAC, but the actually doing that it's not specified in any kind of interoperable way. And note that the salt exists underneath the string literal that will be computed for the digest. So to actually make that work for an HMAC, you would have to parse the string that's supposed to be considered opaque, basically at that layer, pull out that, and then use that as the key. And then I don't know if you're supposed to leave it in there for the computation of the digest. Like, these are all questions that could be answered, but they're totally underspecified. And then you have the name also is, so I did some Googling, and the only results for digest derivation algorithm are this draft and the comment where Christian suggested it. So I don't think it's an actual term. That's sort of aside, but the names are too long to, like, just from JOTS, we try to do things shorter, so like digest derivation algorithm, like it just but I think the real problem is the applicability of the two different algorithms. Is to Hannes's point, like it either needs to be built in a way that it can actually accommodate the two or not. And I think actually the use of HMAC here is, it's sort of questionable, the need for it, based on things that like Neil had said. He was worried about length prefix or length of pension. I don't even know, but the fact that it's using JSON, and it's not really a problem. Referring back to the JWS alg for HMAC is also, like, conceptually, I know what you're trying to do, but from a spec implementation standpoint, it's not appropriate or interoperable at all. And then you also have basically a namespace here that's covered by two different registries, and you could also extend it yourself. So that doesn't really work either. I don't mean to be overly critical, but it's sort of like the idea sort of makes sense. The realization of it is not there. It needs a lot of work. And I think I had some other annoying comments, but Daniel's got it.
Do we have GitHub issues for that?
Yeah.
No, because there's a lot to describe it. I didn't know how to write it down. So I wanted to take the opportunity of face-to-face time to explain the rationale, but I will add a GitHub issue that at least mentions maybe not the specifics, but the brokenness of it. Thank you.
So maybe like just for Hannes's, because he's taking notes, like, can you summarize some, like a sentence to allow?
So I think the summary is the edge derivation algorithm is too complicated, and how HMAC can be used is completely underspecified. So either specify it or delete it.
I think that's a good summary. Yeah, it's problematic. It needs, I don't know how to summarize it other than it needs to be either simplified or vastly expanded.
If someone can find an issue, we can discuss there. Like if we want to, clarify, or we want to take it out the optionality itself, right? Because there are a few people asking for that, but I agree that yes, you have to, take it out, and then the treatment of thought as a key becomes problematic. Thank you.
John.
John Bradley. I'm going to largely agree with Brian. What you're trying to do here is sort of isomorphic to KDFs. You're just using the key as the hash or as the digest. So I would probably try to name it similarly, because essentially for key derivation functions, you have either a straight hash or HMAC, et cetera. I mean, you're just using it for a different purpose, but they're essentially the same algorithms. So I would either take it out and just say you have to use hashing algorithm, or you need a lot more specification. Because, yeah, whether you leave the nonce in the thing that you're hashing gets complicated.
Yeah, we need to look into this.
Yeah.
Great. Yeah, thanks for the feedback. Appreciate it. Should we go to the next slide?
Yep.
Okay. So the last slide for my part, I think, signature validation. This is for holder selected disclosures, Jot. So as I think we've said before, it can be signed or can be unsigned. So we updated the validation section to make clear that when verifier verifies the holder selected disclosures, that becomes a crucial for security of this mechanism, that the verifier actually, does all the validation, computing hashes, whatnot. So it should be not passive in a sense that it's signed, I'm going to verify. No, the verifier must have a policy, whether it accepts, whether it requires signing on the holder's signed disclosures Jot or it doesn't. So if it requires signing, meaning it requires holder binding, where it validates that the signature on this HS disclosures Jot is done by the key signed over by the issuer. So the user is proving control of the same key both during the issuance and the verification. If that feature is required and this HS disclosures Jot is not signed, verifier must reject. Like that, just, like if you want it to be signed and it's not signed, blank reject. If for whatever reason, trust framework policy, the verifier is okay to not have a holder binding, and there are legitimate use cases that are okay with that. If that is your use case, you could accept Jot's using non-algorithm is the clarification we added. I see.
Brian.
Brian. There's a lot going on here. It's complicated, and I don't have a specific issue for this because it's hard to express, but the the inclusion of the disclosures element underneath a signature, I believe, complicates things sufficiently that we shouldn't do it.
Yes. We
agree?
get to that later.
Oh.
We have a proposal, yeah.
Okay, I will shut up then.
No. Thank you. Yeah, and let's get to that section. So yeah, go ahead.
Is it a good idea, or are there good justifications for not having a signature? It's like
Yes. There are use cases where you don't need holder binding. So you just want to know that a document exists that was signed by an issuer for some user, so for some end user, and you don't care whether it's the user.
So the holder binding does not have to be cryptographic holder binding. It could be claim-based or biometric-based. So there are use cases are people trying to combine that with this disclosure feature. So that's another kind of why it's not always mandated. Uh-oh.
Tony Nadlin. Question, is the holder binding meant to do device binding also? So there is a little bit of a difference there. So I'm just trying to understand whether you want this to cover device binding or not.
Yeah, I guess it depends on the. Yes, it can be. It depends on the verifier.
Right. I just didn't see any recommendations in the.
That's right.
So that would be one area that needs to be.
Yeah, can we document in the minutes to clarify the relationship between holder binding and device binding? Thanks, that's a good point.
Yep. Okay. Any more questions? No. Okay, next slide, please.
Takes time to get there.
Yeah. Okay, a word on the encoding that we're using. I think this is actually the old slide set, is it? Yeah. Anyway, let's try with that. So one problem, maybe next slide. This was actually. So we have So there are a couple of slides that we didn't want to show, and we marked them as not show, but they're in the PDF anyway.
Yeah,
but,
the PDF doesn't work like that.
So we'll skip a few slides here.
Okay.
But this one is good. So when an issuer creates the SD JOT, it takes the data, for in this case, an address claim with a street address, locality, and so on. Then transfers that to a byte string, obviously, to then hash that and sign it. So that's a very simple process. Next slide, please. Now there's a complication. The stuff is sent to the verifier, and the verifier needs to do the same computation. So the verifier has some data, transfers it into bytes, hashes it. And obviously, next slide, please, the verifier also gets, so looks at the SD JOT, and there are some signed hash values. And the verifier now checks whether the signed hash values are the same. And in this case, and there might be cases where that doesn't work, especially if the data that is transferred from the issuer to the verifier is modified between the issuer and the verifier. And such things can happen when you transfer JSON, because in JSON, the order of elements is undefined, essentially. There's some room for expressing the same thing in different ways. For example, you have that with numbers, floating point numbers, for example, specific things of how to encode Unicode strings, for example, but also white space between the elements in a JSON. So the issuer sends something that is JSON, or has some data, transfers it to JSON, and the verifier gets that JSON and then does the same computation, but not necessarily with the same result. So the byte string that is hashed might be different. And of course, when that happens, there's a different hash, and apparently the signature check will not work. Although the same data was transferred. So here in this case, you can see that street address and locality, they changed the order, and the white space is different, and so on. And that's a problem, and that's a problem we need to address. Next slide, please. there's essentially two different approaches that you can take. One is to send the exact bytes that were hashed from the issuer to the verifier. So I call this the source string because so the source of your hash. Or you can apply a transformation both at the issuer and at the verifier that ensures that both really hash the same byte string. So both end up with the same hash at the end of the day. So that would be canonicalization, where, so this you need obviously to do at both the issuer and the verifier. In any case, whatever we do, we need to define what we do in the spec to ensure interoperability. We need to ensure that issuer and verifier agree on how this computing is done. There's a question by Hannes.
Yeah.
I obviously have some more slides on this topic.
Yeah, I wanted to walk around. I think you have to do both anyway, because if you think back about HTTP,
Yeah.
also the HTTP signature work we did, it's the same problem if you just compare the hashed value or take the hashed value to do further things, then and not compare it to what was originally hashed. So you have the same issue again, then you will run into problems because someone attacker could swap out things because you are later do all the actions based on the transmitted hash value. And while you actually base decisions on what's in the content of the original plain text, that would be a problem. So I think you have to do at least the canonicalization in some form. No, you don't think so?
Not necessarily.
Okay, I'm looking
So-
forward to see that.
Just one comment. So that was Hannes as an individual on the mic.
Okay, let's see if we can get the slides back.
No idea what's going on there. It's not working. See? I'm trying.
Oh, you lost
It is connected. I don't have power even. Like I thought I didn't have that power. Still trying to connect here.
Do we have some waiting
Yeah,
music?
I'm just trying. Yeah.
Yeah.
Yeah, Hannes will start singing in a second. Okay, I think I'm back here.
New screen has been shared.
This guy. Oh, shit, where is it? Here. And beautiful.
Yes.
Yeah, no worries.
Cool.
Okay.
Thank you very much. Next slide, please.
Ah. Is this one?
Yes. So the approach that we've taken in the draft is to ensure that a byte string is transferred from the issuer to the verifier. And because we transfer the byte string, we can ensure that always the same thing is hashed because you just hash this byte string. If you look closely here, on the top left side, you see the address. And now it's not a JSON object any longer. Instead, it's a string of bytes, which happens to encode JSON. Actually, you could use any other encoding at this point. But JSON is just something we use anyway. So what we do is we build one string per object. So that object can be an address, in this case, like a complex JSON object, can also be just a JSON string, can be a floating point number, whatever, but it will be turned into a string by JSON encoding. And that string is transferred from the issuer to the verifier. And that ensures that both hash the same byte string and come to the same hash at the end of the day. Next slide, please.
Yeah, it's good.
And next slide was one of the slides we Yeah. So canonicalization gives you a clean data structure, so you can just transfer things essentially as they are. But the problem that we saw with that is that it adds a really non-trivial dependency. So you need to ensure that issuer and verifier follow exactly the same rules, that there are libraries for that implement that. And if you happen to implement it yourself, or the library is not well implemented, it can be really hard to debug because the issuer just sends you something, but you will never learn what the issuer actually hashed to get to that hash value that you get alongside. So this can be so obviously you can test that, you can do conformance tests and so on, but if you happen to have an error somewhere, it's really not transparent to the verifier what's happening, and it can be really hard to debug. Next slide, please. So the approach that we've chosen, the source string encoding, is really easy to implement with any JSON library. That's also feedback that we got from the implementers of the spec. You just do a JSON encode on a thing and you're good to go. You don't need any new dependencies. So you just need the JSON library. And it's actually something that in a similar way is being done in JWS anyway. So you have the whole JSON thing and you just hash over it. The downside of this is that it certainly looks strange. So some people ask if that's an error in the spec. No, it's not. That's why we have this lengthy explanation now. And of course, if you just look at the disclosures object where the raw strings are in, you don't, so if you just have that thing, you cannot apply JSON schema to, in the example, the address claim, for example. You cannot really talk about typing, it's always a string. So you have one layer more that you need to dig into. So might not be accessible to such things. But hopefully at the place we're using it in the spec, it's not a place where you would do that, because you process a thing according to what's in the SD-Drot spec. And at the end of the day, you get a document out that has the same data as the issuer processed in the first place. So you get the same types, the same object, and so on. Justin.
Justin Richer. Not exactly. So JSON strings have the ability to have, for example, Unicode encoded characters and stuff like that, that allows you to put a different character sequence and get the same semantic bytes out the other end.
Yes.
So this is something that you can do and say it's the JSON string value, but you have to be way, way, way more precise than just saying call JSON.encode. Because, for example, inside JSON strings, you are fully allowed to prefix forward slashes with a backslash character, and that gets sent as a 2-character thing, but it is supposed to be interpreted as a single backslash character, as a single forward slash character. You can also send the forward slash character without the prefix backslash, because it's technically not an escaped character, but you're allowed to escape it with the same semantic meaning. There's also the /U Unicode characters, and then there are some JSON libraries that do really, really weird things with Unicode characters without doing the /U prefix encoding and just chucking it in there and hoping for the best because it's using the system's underlying string libraries. In other words, this works until it doesn't. And when it doesn't, it goes really sideways, really, really hard. So if you're going to be basing this off of JSON, raw JSON strings, you're going to need to be incredibly precise about how you actually pull those bytes out, because your normal test cases and your normal use cases are probably going to work most of the time until somebody gets a weird library that is implemented completely compliantly that does something that you weren't expecting. So it's not as easy as it might seem to say JSON strings. And on top of that, I would encourage the authors to look into the It's a bit of a pariah RFC, the JCS. Yeah, I see a lot of head shake. Exactly, because that's what you're doing.
Let me just say something here. I think so. Either I don't see the problem yet, so I would be happy to discuss that with you.
Sure.
But as far as I see this, we do the JSON encoding. So we take like the address object, right?
Right.
We call JSON.encode. We get a string. And that string is sent as part of another JSON object from A to B. Of course, you can add backslashes and Unicode escapes and so on there. But you are still like you call the encode on one string and you call the decode on the other string and you get the same data. You get the same byte string. We are not hashing the thing that was already encoded. So hard to explain because we do two encodings here. But
right.
As far as I see, and correct me if I'm wrong, when I have any byte string and I call JSON encode and I call JSON decode, I get the same byte string, right?
Kind of.
Kind of?
Sometimes.
Well,
usually.
So, like, not on the wire.
Right, I know.
Not on the wire.
Right. So what I'm saying.
A and B see the same byte string.
Sometimes, usually.
Yeah. So that's the expectation that we have, and I would be happy to see that invalidated. But
it's a beautiful expectation. So what I would say is that where you need to be precise in this is where exactly in the encoded versus decoded versus stuff stack you're expecting to be able to get those bytes. Because if you're throwing things through, especially a JSON decoder on the far end, it's already gone through a JSON parser, most likely because it's an encoded string. So it's been parsed as a JSON strings. And so that's been already turned into something.
Not the inner thing.
The inner thing has been parsed as a JSON string.
It's a JSON string, right?
Right, exactly. So that's already been through one round of JSON parser, which can do all sorts of stuff to the insides of the string and change the bytes that were on the wire. So what I'm saying is,
we don't care about the thing on the wire.
I understand that. I think that you need to. So anyway, we can talk more. There's weird stuff that happens in the wire. Don't reinvent JCS. It was a bad idea then. It's still a bad idea. And
that's why we're not doing any.
So maybe just quick question to you. So are you advocating for canonization, or are you saying just we want to be precise with this approach?
I'm saying that if you're going to do this approach, you need to be very precise about where exactly you're saying get the byte stream.
Okay.
And because there are some subtleties in implementations that are going to burn people in weird and unpredictable ways. This is going to be the corner cases and the edge cases that really, really get you here. The day-to-day stuff, chuck it in JSON encode and JSON decode, it's just going to work. Completely agree with that. That's it, like the vast majority of cases, it's just going to work and that's fine. But in order for this to be a real robust security spec, as we know, we need to care about those corner and edge cases. And this type of, if I'm getting it, I've already called JSON.parse and now I'm calling JSON.decode on something. Maybe that's already been called or maybe that's not been called.
We're not calling parse and decode.
No, you're calling parse in order to get it out of the object in the first place.
Yes, that's it. I don't do the decode afterwards is just to look at the value inside, not to.
Yes, I know. Yeah.
Okay. So
anyway, I know what you're doing, and I think that you have to just say basically in this part of your JSON stack, this is where you grab the bytes, and you should be okay.
Yeah.
Okay. So in principle, you don't have a problem with the approach. You just want precision here, right?
I'm saying if the approach is this, then it needs to be very, very precise. I'm not making a value judgment on this approach one way or another.
Okay.
Okay. Thank you. Next slide, please. Sorry.
Ori.
Ori Steele, Transmute. Agree with most of what he just said, but I think generally you're doing canonicalization, whether you want to call it that or not. That's it.
That was my point.
Yeah.
But
Okay, so
To be canonical for
Seems-
between
better
issuer
call it
and the
differently.
verifier. It has to
Yeah.
be canonical for, yes.
Mike Jones, Microsoft. I'll actually disagree with Ori's last point. I think what they're trying to do is hardening the string for transmission. I mean, a lot of the Jose stuff uses base 64 URL for hardening in the same way. I'm not saying you want to use that choice or not, but the point is to get a string that's going to survive transmission.
Exactly.
And I hate canonicalization.
Just for the record.
Thank you for not doing that.
Yeah,
hardening is a different word of canonicalization.
yeah, okay. You're on.
Yaron Schaefer into it. So, sort of a follow-up on what Mike just said. You're starting with the fullness of JSON and all its complexity as a prerequisite. You want to essentially support disclosure of anything that looks like JSON. And my question is whether you can harden it enough. Maybe, for example, by putting constraints on claim names, on cardinality. So can I have multiple claims of the same name, stuff like that? Maybe, yeah, the encoding of claim names
That would be
so that
canonicalization.
the security doesn't depend as much on the implementation details of these libraries.
I think that would be canonicalization, right? If I say like this needs to look in a very specific way.
Okay, I'm gonna cut the mic after you're on, so because we need to move on. But yeah, go ahead, Dave.
Yeah, but I don't see it as canonicalization, more of can I have, a well-defined claim document that's still securely robust.
Are you talking about, for example, saying do not put backslashes in the actual claim values, so you don't have a problem, or
Probably not values, but claim
in the claim
names,
names? That's what you're saying. So like
stuff like that.
I'm not sure if that avoids the problem here. But, yeah.
Okay, let's
So
keep going.
how are we?
Yeah, a few minutes. Like,
minutes.
I'll-
Okay.
yeah.
I try to do this in a few minutes now.
Yeah.
Next slide, please. So this is just a quick example. So this is what this is an SD jot. So what the issuer creates, the issuer signs and then sends to the holder, and the holder can send this to the verifier. This is essentially, so not many changes except for the names there from the last presentation. So these are the digests, the hashes of the claims of the values. So now what are the values? Next slide, please. They are then, of course, transferred in what we now call the II disclosure document or issuer issued disclosures, formerly called SVC. And here we have the strings. So for sub, you see a string. For given name, you see a string. And each string then encodes the JSON object. This JSON object itself has two keys, S for the salt and V for the value. And this approach is also nice because it ensures that you have a separation between the salt and the value, which means that there can be no hash length extension attacks or anything like that, where part of the salt is considered like part of the value or vice versa. So it's clearly separated. If you don't do it this way, you need to think about how to take the salt and the value and then hash them together. You need to define that step as well. We don't need to do that. We just have an object S and V, salt and value. And of course, that whole string for birth date, for example, then hashes to what's in the SD jot. Next slide, please. Next slide. This is then, so the issuer issued disclosures is created by the issuer, sent to the holder. The holder selects some of the claims to disclosed to the verifier. So the HS disclosures document is a subset of the issuer issued disclosures document. In the current spec, the same document is also used for the holder binding. So stuff like anons or audience or other things can be added into this document, and then the whole thing can be signed and sent from the holder to the verifier, and the verifier can then verify that this was actually signed with the holder's key. Now, coming back to what a point that Brian raised, this thing, as we have it in the spec right now, actually serves two different purposes. One is to just transfer the holder's selected disclosures. You can essentially do that unsigned. There's no real need to sign that thing. You could just send it as a JSON object. And then there's the holder binding, which is just a signature over the nonce and the audience, wherever that nonce comes from, by the way. And that is a different purpose. So that is to show that the holder is able to sign something that's fresh because it has this nonce and intended for that verifier using its key. So two different things, and we could think about separating them. So just having a JSON object for the HS disclosures, and then optionally having a signed JOT for the holder binding. That's an option that we probably will consider, I guess. Questions?
I think we need to move on.
Okay.
So if you have questions, maybe just raise them and make sure people, and we can discuss it in the side meetings if you want, right? Okay.
Then next slide, please. We also have claim name blinding now. So some of the claim names can be replaced by random strings. In this case, I don't know what it was, family name? No, family name. Anyway, this claim was blinded, so it has been replaced by a random string. The issuer selects that random string and just exchanges claim name and the random string. Next slide, please. In the disclosures, we now have an entry for the claim with that random string. And we now have a third element in the disclosure, which is called N for the original claim name. And that element just contains the original claim name. Now, this might look like complicating things further for an application consuming SD-JOTs, but we'll get to the processing model where we say, okay, the SD-JOT library can do all the hard work on processing this, putting in the original claim name instead of the blinded claim name, and the application will just get a JSON document that will not have any traces of the blinded claim names. Next slide, please. Processing model, how fitting. So this is the processing model.
How many slides do you have?
That's just
Okay.
just closing everything.
Okay.
The processing model is how we think that SD-JOT libraries will process SD-JOTs. Simple steps: verify all the things that you get, verify that the disclosures actually match the SD-JOT, unblind any blinded claim names if there are any, merge the selectively disclosable claim names claims into the non-selectively disclosable claims in the SD-JOT, which means that at output time, you get just one document which looks like the body of a normal JOT, which has been verified, processed, and you can just put that into your application. So the application doesn't need to know anything about SD-JOT. Next slide, please. Okay, next slide. We now have 5 running implementations. So we have our implementation that we keep up to date to generate all the examples in the spec. And we now have a new TypeScript implementation, second TypeScript implementation as well. Next slide. Yeah.
Oh, come on. There you go.
Just really quickly, next steps. I think we need to think about how this can look like in the context of other existing credential formats. If there's a mapping between them, if this is completely different, we need to think about that, probably create some examples and discuss that with the relevant groups. We still need some security and privacy considerations, and it would be great if at some point we could do an interoperability test between the implementations that we have. We could even do that offline because you can just create these things and consume these things. You don't need to be online for that. Thank you very much.
Thank you, Daniel and Christina. Do you need time off, like on the side meeting, to continue this discussion? Okay, sounds good. Okay, awesome. Thank you. Brian, let's get ready. I'm gonna pass the control to you. Where are you? Here. Go here. Pass the control. There you go. Got it? Yeah, there you go.
All right, tough act to follow. I'm here to talk about the step-up authentication challenge protocol. And yeah, so including a picture, as Aaron said, is sort of fundamental. This was actually taken IETF 89 back in, I don't know, a while ago. So without further ado, let's move forward. So a little bit of backstory context. I have a hard time presenting without providing some context. I'll try to get through it quickly. Basically, a protected resource can technically reject a technically valid access token for whatever reason that it wants. Maybe a risk engine decision, some local constraints. I say here bad vibes. Like really, whatever it decides is a reason to reject that token. It's totally within its purvey to do so. And really, oftentimes what a resource wants then is a token obtained from a more recent user inactive authentication event, or a token obtained with a different authentication flow, probably a stronger one. And there's no current standardized guidance on how to do this for the RS to express those requirements down to the client, and the client to indicate those requirements back through to the authorization server in the flow to acquire a new token. My phone locked. There we go. So we, Vittorio and myself, tried to address this through a draft in the working group process, so forth, so forth. The summary of the draft's approach is extending RFC 6750 with a new error code, insufficient user authentication, and a new parameters on the www authenticate header, ACR values, and max age. And this gives then the resource the opportunity to express down to the client the conditions that we previously talked about, either and or both, that a different ACR value representative of the authentication flow or authentication context, or a more recent authentication event is required associated with the access token that will be issued off of. In turn, then we utilize the authorization request parameters, ACR values, and max age to allow the client to convey to the authorization server its needs around the authentication event. These are parameters already defined and registered via OIDC core in the our OAuth parameters registry. And then define and or reference, depending on the context, ACR and auth time introspection response parameters and JWT claims to express that information about the authentication event associated with the access token to the protected resource. So really it's just stuffing them in the JOT or making them available via introspection via the same claim names. They're already defined for JOTs, we just reference them. They're more explicitly defined in this draft for introspection, to be clear. And this is the kind of flow diagram. I'm hesitating whether it's really worth going over. Basically, you're making API requests up before one. You get to one, a token's presented. It has token information. The protected resource decides, hey, it's not good enough. And in this case, it's challenging in step 2, basically saying, I need a more recent authentication event associated with the token that you're presenting me. As a result of 2, the client pops up a browser or directs the end user's browser to make a new authorization request, and includes, in this case, a max age parameter saying I need a more recent event, authentication event associated with the access token. Then the magic happens all out of scope, but the authorization server prompts the user, does the authentication dance per its purvey, and ultimately returns a new access token in step 4. Some things omitted there, but hopefully you know the drill. And then in step 5, it makes the same API call with the new access token. Inside or referenced by that access token is a more recent authentication event represented by auth time. Same flow could happen with ACR, but I'm using auth time here. And the protected resource is happy with it. Keep locking my phone. So just kind of quick summary of where we are. In Vienna, we first presented this draft back in IETF 13. It was adopted and shortly after that, and followed by the pretty typical sort of standard iteration process, some comments, some new updates, so forth. We got drafts 1 and 2. And then talked about it in Philly. A few things have happened since then. Published 3. Clarified that the ACR values and the max age can occur in the same challenge when and if they're necessary. Sometimes you want to ask for both. Fleshed out the deployment and security considerations. And also did all the IANA registry stuff that's necessary. Tried to clarify, because it wasn't clear to everyone, that while the ACR values, which is basically saying these are the accepted ACRs that we would take for this, can have more than one value. It's a space separated listing of ACR values. The actual authentication only can be qualified as meeting one of those, so the token itself only has a single ACR, only one ends up in the token. We did migrate this over, and by we I mean Aaron, migrated it over into the new GitHub org here, and thank you for doing that. We're coming along to the new process, but it's nice tooling, it's very, very useful. Did working group last call was September 22nd to October 2nd. Did drafts 4 and 5 to mostly editorial updates and feedback, addressing those, and then they were the day after each other, noticed that the updates needed some updating, so we fixed those. Recently, I updated some examples and figures to be really clear that the authorization request is sent by the client, not directly, but via directing the end user's user agent or browser to make the call. In some ways, this is related back to the discussion of cores, although it's not mentioned here. What happened here is I was actually sort of refurbishing Vittorio's slide deck to do these slides, and it became kind of clear that the ideas had been intermixed, and that some of the slides made it look like maybe the authorization request was coming directly from the client. Didn't say that, but it maybe implied it, and I wanted to clarify that. Look back at the draft, and it in fact had the same kind of potential for ambiguity. So I fixed those, and I say a new draft is coming soon. I actually published this yesterday. There's no normative changes, but I think it's an important clarification that maybe folks that are familiar with OAuth would just sort of gloss over because they know how it works. But if you're reading it kind of literally, I think it's important clarification and fix. And then hopefully anticipated soonish will be the Shepherd's review here. And I know the Shepherd, has a lot going on, including a COVID bout that slows some other things down. But no pressure, but that's kind of where we're at with. Hopefully soon. And someone recently kindly pointed out that IETF 16 is not in Prague. I was so eager to include a picture here. And I don't have one of Yokohama, and I'm going to miss Yokohama, that I got confused myself. But looking ahead, hopefully this will be the last time seeing a presentation about this. I will be probably in Prague, but I won't be in Yokohama to talk about it anyway. So yeah.
So quick question, that there was, Taka had provided some feedback on the list, and there was some discussion there. Do you know the summary of that discussion? What's the status there?
The summary was some back and forth between him and Vittorio. Ultimately, he sort of came to it would be nice if you said a little something like this, but it's not a big deal. And he said he wouldn't push for it to be changed, which I appreciated. And I am personally of the opinion that what he's asking for only complicates things more than it confuses. Either way, it's not protocol level. It's just clarification. So
Okay.
I think the output is nothing's going to happen.
Okay.
But if you check the thread, you'll see that, that's consistent.
Okay, I'll take a look. Anybody else has any comments, questions?
Daryl Miller, Microsoft. Just one call out, if you're adding a new parameter into the authenticate header, I don't know, have you looked at the structured fields work? There's an effort to try and standardize how structured fields work, and there's some work going on in the HP working group to retrofit existing HP headers to use more standardized ways. And you mentioned about space delimited. I need to look into it, but that might be the right way of doing it. It might not fit into the new structured header fields world.
Is authenticate one of the ones they're retrofitting?
It isn't in the spec at the moment, but I believe there is plans to do that. Mark Nottingham would be the one to.
I can take a look at it. Timeline may or may not make sense on actually referencing that. The space delimited thing is actually another layer. It's within the value itself of a parameter of the header, and it's defined. I'm not sure
there is an inner list thing instructed that is space limited. It might fit. Anyway, if there's an easy way of making it fit, we should just try.
If there is, yeah, thanks.
Okay, thanks, Daryl. Somebody in the queue, Jaimandeep, go ahead.
Jaimandeep from Forensic Sciences University. So I was just wondering, like, if we want to include the other parameters also, which are going to the protected resource server, like client authentication parameters, like if we are also looking at that way. Yeah, or maybe it's out of scope for the present draft RFC.
Okay, I'm gonna cut the mic after Jaimandeep. Go ahead, Brian.
So generally speaking, it's sort of beyond the scope of what we're trying to accomplish here. It's obviously a lot more to that's been discussed sort of ad nauseum in the thread, but that for a number of reasons, that stuff isn't applicable, or either isn't within the scope of the draft, or isn't technically makes sense in the context of where these things are communicated. So
okay. Okay.
Next steps. What should I write down?
Yeah.
Next steps are just published 06 with, so that's been done, and basically awaiting the Shepherd write-up at this point.
Okay.
With no time pressure on that, but
yeah.
Seriously, but that's where we're at now. Is waiting Shepherd write-up.
Okay, awesome. Thank you, Brian. Appreciate it.
Thank you.
Thank you. Okay. I see Ben is on the line there. Let me pop your slides here. Let me see if I can hand you the control, Ben. Hold on. Where are you there? Okay. Need to find you first. Oh, here. Oh, no. Can't do it. Oh, here, from here, maybe. For some reason, I can't. Okay. That's fine. I'll drive the slides,
okay.
Ben. When you're ready.
So, hi, everybody. This is a new draft. Next slide. That's the long title, but I think the short answer is that this is about pop-up authentication. So this is what login looks like on the web today, thanks in part to the great work of people in this working group. We have this single sign-on ecosystem. We have a bunch of very rich ways to authenticate users very securely through YubiKeys and passkeys and all sorts of great new innovative stuff. Next slide. This is what it looks like if you're not using the web today, if you're trying to use HTTP standards outside of the web context. So on the left, we have a CalDAV login screen. On the right, we have a proxy authentication login screen. These are the state of the art, respectively, for CalDAV, for proxies, and in general for any login system that doesn't benefit from a web browser. Next slide. So non-web login is basically stuck in 1996. These standards have, in my view, not significantly changed. Next slide. So what about OAuth? I'm here because I'm definitely not an expert on OAuth, and I want to get input from this group about how to address this problem and bring these systems into the modern era. But my understanding is that OAuth generally requires the client to know in advance who it's going to be talking to. And this is really about clients that want to be able to essentially access any HTTP resource on any domain, subject to potentially an authentication prompt, with the only requirement being that the client and this origin both implement a defined standard. Next slide. So here's the user experience that I'm kind of imagining here. It is laid out actually this way in the draft. So you're going along your business. Maybe you've just changed a configuration setting, or maybe you're just going about your business on your device, and you get a notification that something on your device is requesting interactive authentication. And so you can open your browser, which will open to essentially a login page. You'll go through some sort of probably OAuth driven single sign-on, probably server to server OAuth. And then at some point, there will be a signal that comes back to your browser that says authentication has completed. And at that point, the browser window will close. You'll see a second notification. You're done. And now you go back to whatever you were doing. Next slide. So this is the specific protocol that's laid out in the draft, but this is really, I think, kind of a placeholder. I would really welcome some more input on how to structure this exchange. But in this case, the client says, hey, do you support CalDAV in this example? And the server says, who are you? Open a browser. Or you can see there are other www authenticate response headers here. So there could also be other, maybe more old-fashioned authentication options presented in the challenge. Next slide. So that www authenticate header had a parameter called location equals /login. So that tells the client where this login page is. So the client now opens a web browser, and that web browser is instructed to load this page. And so here we get back, again, a 401 response, but this time it contains HTML telling us the login instructions. Next slide. And now the client does something, clicks buttons, enters passwords, taps YubiKeys, navigates maybe between different origins and approves things. At some point, the client comes back and the browser fetches this login page again. This time it sends that fetch with a cookie that's been set in some part of that flow. And now it gets a 200 response, which is the signal that means we're done here. So the browser closes. Next slide. And now we're back in the non-interactive part of this. So now, again, the CalDAV client is trying to load this endpoint, but it copies that cookie header out of the successful request from the browser into the CalDAV client, and now it can actually speak CalDAV to that endpoint. Next slide. So this is an overview of the proposed protocol. I want to focus on step 5, step 4, where the browser loads the authentication path. And if that authentication path ever loads successfully while this browser instance is operating, the client copies all those request headers out of the request and then kills the browser. And then those headers are copied into any future requests that are made by this non-interactive client trying to reach that origin. So next slide. There are a lot of interesting corners that come up in this, again, this sort of placeholder, particular instantiation of this idea. Like the draft says cookies and authorization headers are both allowed. Authorization is more natural, I think, in this context, but and my understanding, it would force us to use JavaScript in this browser context. It would be nice to be able to support non-JavaScript browsers. Why not? Cookie seems to allow us to do that. But then my personal use case here is really related to these proxy clients. So we need to convert authorization headers for the request to the browser into proxy authorization requests for the proxy, and that's natural enough. But what do we do about cookies? So the draft says, fine, you can't use cookies for that, but we could define some way to copy those cookies to a proxy server. There are some interesting UX implications about your OAuth type token expires at some point with some system service. You want to refresh that, so we need to we're interrupting the user at some random point in their day to say, oh, please re-authenticate. But that's enough about this. Let's move on. So this is a brand new draft. It's designed to bring all of the great OAuth-driven single sign-on and two-factor login stuff to the sort of the rest of HTTP, or the rest of standards-driven HTTP. It definitely needs more input from folks like you. I'm especially interested for this group in what components here could be shared more with the OAuth ecosystem, or even, is there a way to express this in OAuth? And by the way, I'll be repeating this presentation, I believe, tomorrow morning for the HTTP API working group to get their input. And I think I'm seeking adoption here, and I think it's an interesting question of where that adoption would live. And if you want to see more use cases, I would mention the access descriptions draft in Mask. Okay, that's all. Aaron?
Thanks, Ben. Aaron.
Yeah, hi, Aaron Perky from Okta. If I were to rephrase this in terms of OAuth terms and roles that we already use, it seems like it's almost everything is already there to make this work, and there's really only one thing needed. So it sounds like what you're trying to do is drive an authentication event when a resource is requested. So we have the in I think it's 6750 talks about the error response when a client makes a request to a resource server that does not contain a token or contains a wrong kind of token. And that's also what the step-up auth draft is sort of getting into as well. And what we don't have in that draft, or I don't think any other ones, is the concept of the resource server driving the location of telling the client where the AS is. And that's kind of what you're asking to do. Of a calendar client shows up and says, I know what resource server I'm talking to, try to make a request. That resource says, you need to log in. Here's where to go log in, where the client doesn't necessarily know that before. And I think you're right that most of the OAuth work is the other way around, where the client knows the AS ahead of time. But that's the only missing piece. Everything else actually already fits into the OAuth world. So I think I don't think you need to define a whole lot of new things. And I think that the only piece needed is defining the location of the AS at the resource server, which would then do all the normal OAuth steps after that. So normal authorization code flow. You don't need to define any new things about what to do with the extra headers and cookies and stuff, because all that would just sort of piggyback off the existing flows.
Like we have just a few minutes and we have a number of people on the queue. So I'm gonna give people a chance to give their comments, and maybe we can take it after that offline, okay?
Okay, yep.
And so are you done with your comment?
Yeah, that's what I wanted to say. Happy to talk about that more, and maybe some of us here can chat about it too.
Okay, thanks, Aaron. Just one, John, just hold on. A few people in the line there. Armando.
Hello, can you hear me?
Yes.
Okay, just one quick comment. So basically in the Privacy Pass working group, we are working on one solution very similar to what you are proposing, which is basically just increase a new option in the HTTP authentication header, so you can do this kind of authorization mechanism. So please take a look on the Privacy Path group. Thank you.
Thanks,
Okay,
Armando.
I'm a co-chair of Privacy Pass, so I definitely should take a look at that.
Good. David.
I just wanted to point out that there was an internet draft, I believe, a while back where someone proposed, it might have been Nat Sakamoto, to use the link header to advertise the AS that could fulfill that 401.
Okay. Thanks, David. Philip.
Thank you. I want to piggyback on what Aaron said, that when he, and I'm gonna quote, we have everything pretty much apart from one smaller thing. I guess that it depends on who the draft expects to drive this orchestration, whether it's the client running inside the JavaScript inside the browser, or whether it should be the user agent. The presentation did not clarify that for me, and if that's the user agent, then this is really just limiting to web experience, and it cannot be extended to use, I mean, to authenticate CLIs, etc., because then there is a handover of information from the browser to a CLI that we currently do not have.
Yes, this is definitely meant to be compatible with a CLI experience where you've run some command and your tool complies with the standard and pops up a browser window, which then closes when authentication is complete.
So you're expecting the client inside the browser or whatever to orchestrate all of this?
That's right. This would all be driven from inside the web page essentially, but the CLI needs to have its fingers inside the browser to be able to pull out these outputs, right? It needs to be able to pull out these authorization or cookie headers for then use essentially by a different user agent. There's a browser user agent, and then there's this non-interactive user agent.
We're out of time, so let me give John a chance to wrap it up here. John.
I think this is a interesting idea that needs to be explored. When we were originally doing OAuth, if memory serves me, the error from the resource server returned what scopes were required, but we explicitly didn't say what the authorization server endpoint was because there were a number of security concerns around essentially having the resource server being able to do phishing on the user. So we have to think about if we're going to change the model, and yes, Nat did have a draft around that, but if we change the order that these things are happening in, we have to do a deep security review as to what those implicate, if there are any unintended consequences of that. The other is that as one of the editors of the FIDO specifications, there are a bunch of things in browsers that stop web views from being able to use WebAuthn, etc. So exactly how you're calling these things, if you're planning on grabbing headers out, etc., that may be at odds with the security that browsers and the OSs are implementing. The other thing that you should probably talk to Google about is that they're doing a bunch of work on proof of possession for cookies to prevent cookies from being exfiltrated outside of the browser. So that may also be somewhat at odds. So there's a bunch of things that have to be coordinated to figure out whether or not this can actually be practically used end to end, but it's probably worth thinking about.
Thank you, John.
Thank you.
Ben, just wrap it up now if you have any last minute comments, because we are way past our time.
No, thanks for all that input. We'll discuss on the list.
Awesome. Thank you, Ben, and thank you, everyone. It was great discussions, great presentations. See you next meeting.
Hey, how are you? Good to see you. Oh, yeah? Yeah.
Next time. Anyway, just to make sure we have enough room for people, right? It was 60 something. Yeah, that's awesome, for sure. Okay.
FDA.